just like I said at the beginning of multiplying and dividing radicals, it's important to remember that radicals behave very much like variables. So if I say 4 root 7 plus 5 root 7, you could think of it like 4a plus 5a, and of course we know that that equals 9a. So similarly, 4 times the square root of 7 plus 5 times the square root of 7 is equal to 9 times the square root of 7. We might not know exactly what number root 7 is, but we know that we have 9 of them. The other thing that I said also holds true, and that is that it's really important to simplify up front to make sure that you know what you have. For example, if I have 7 root 3 minus 4 root 6 plus 2 root 48 minus 6 root 54, you may at first glance think, oh, I have no like radicals, no like terms, so there's nothing I can do. But remember, root 48 is really root 16 times 3, which means I can take the square root of 16 and make this 8, because the square root of 16 is 4, times 2 is 8, and root 3 stays in here. Oh, this should be a 54. And like that, 54 is 9 times 6, so the square root of 9 is 3, and 3 times 6 is 18, root 6. These that we couldn't simplify, we bring down. Now it's just a matter of combining like terms. 7 root 3 plus 8 root 3 is 15 root 3. Negative 4 root 6 minus 18 root 6 is negative 22 root 6. Most of the problems are pretty easy like that. There are some, however, and do require a few more steps. If I say root 15 minus root 3/5, well, first of all, you'll notice that I have a radical in the denominator, so we're going to want to rationalize that first. And remember, if I don't have a denominator, it's 1. So minus root 3 over root 5. And I can't have a radical in the denominator, so I'm going to multiply the top and the bottom by root 5. So that gives me root 15 over 1 minus root 15 over 5. Just like always, fractions need a common denominator. So I'm going to multiply the top and the bottom of this by 5, and I'm going to express the entire thing over one fraction bar. This is now 5 root 15 minus, and if I don't have a coefficient, remember that's 1 root 15 over 5. And my like terms are here. 5 root 15 minus 1 root 15 is 4 root 15, and that entire quantity is over 5. And this is simplified because, remember, we can't cancel out radicals with constants. So this is the final answer. You're only going to have to do a couple of problems that are like that, but do study this example in your book, and make sure you rationalize first. Then find a common denominator. Then add the numerators. And finally, if necessary, simplify.